All right, here are two more of your homework problems from section 5.345. It's 2 square root of 2 times the cosine of x over 2 is equal to the cosine of x plus 2 for all real x. Remember that when the angle's given in x, we're going to use radians. This is a half angle. The way I like to handle half angle is by introducing another variable, a new angle called alpha. Let's do that for this one. Let's see, let's let alpha equal to x over 2. Then let's solve for x, to multiply both sides by 2. So 2 alpha is equal to x. We're going to use this and use a substitution in there. That prevents having to find extraneous solutions and things like that by using, and when we use a half angle identity, that is where all that kind of trouble comes from. Let's go ahead and figure out the range. Normally the range for x would be between, for an angle would be between 0 and 360, or 0 and 2 pi in this case. So we solve for x, so multiply both sides by 2. 0 is less than or equal to x is less than 4 pi. So at the end of this, since we're solving for all real x, we're going to be adding plus 4 pi k to the end of these. Okay, so first let's make our substitution here. 2 times the square root of 2 cosine x over 2 is equal to alpha, so I'm going to call that alpha, is equal to the cosine of x, but x is equal to 2 alpha plus 2. So what I need to do here now is I have a double angle. I'm going to use a double angle substitution. So the one that I'm going to use will be something that puts everything in terms of cosine, because we need to transition our equation into one angle. Right now we have two angles going on. One angle is called alpha, the other's 2 alpha. So we want them all to speak the same language. I'm going to use a double angle substitution. I'm going to use the fact that cosine of 2 alpha is equal to 2 cosine squared of alpha. 2 cosine squared of alpha minus 1. So that's this substitution, plus 2 is equal to 2 square root of 2 times the cosine of alpha. Okay, now I need to solve this equation. So first I'm going to say negative 1 plus 2 is 1. So I'm just going to do that right there. Okay, now I want a 0 on one side, so I'm going to get a 0 over here and say 2 cosine squared of alpha. I'm going to subtract this term from both sides, minus 2 square root of 2 cosine of alpha plus 1. This is what I get here. Now, I need to try to factor this if I can, and if I can't, I'll use quadratic equation. This one, I'm going to use quadratic equation because I don't recognize how to factor with that. So what I'm going to do, just to simplify this, is I'm going to let alpha just be the letter A. And so I'm going to call 2, or cosine of alpha be the letter A. So I can just solve this quadratic equation. 2a squared minus 2 square root of 2a plus 1 equals to 0. Oh no, that's not right. Equals to 0 is what I'm going to solve here. All right, so I'm going to use quadratic formula, which is this. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, this is what my b is, negative 2 square root of 2. My a is 2. So this would be a, meaning this a, is equal to negative b, or negative would be positive 2 square root of 2, plus or minus the square root of b squared, which would be negative 2 square root of 2 squared, minus the number 4 times a times c all over 2a. Over 2 times 2. All right, let's just see what's going to happen here. This is 2 root 2 plus or minus the square root of, this would be 4 times 2. This is going to be 8 minus 8 over 4. I realize that this probably would factor, but what I get here 8 minus 8 is 0, so I get 2 square root of 2 over 4, or the square root of 2 over 2. Oh my goodness, that I recognize. I didn't have to do it this way, but it's fine that I did. Okay, so what I discovered here was I solved for A was really the cosine of alpha. So what I got here was that the cosine of alpha is equal to the square root of 2 over 2. All right, where is that true? Here's my unit circle. The cosine is positive over here in quadrants 1 and 4. The cosine is equal to square root of 2 over 2, or 1 over the square root of 2, right here at the 45 and right here at the 45. So, this would be at pi over 4, and this would be at 7 pi over 4. Okay, now, that's what alpha is equal to. But we're really solving for x, right? So, for x. So, x is equal to 2 times alpha. So, so alpha would be pi over 4. Alpha is 7 pi over 4. Can you see that? Okay. So, but really alpha is 2, x is equal to 2 alpha. So x would be 2 times pi over 4, or pi over 2. X would be 7 pi over 4 times 2, which would be 7 pi over 2. But, let's see, they want it for all real, they wanted it for all real x. So, we're looking at pi over 2 and 7 pi over 2, which is, let me see what this is. If I subtract 2 pi, that's here and here, I believe. So I could write this real succinctly as pi over 2 plus 4 pi k, or I could write it as 7 pi over 2 plus 4 pi k. We'll also write that one, 7 pi over 2 plus 4 pi k. I think there might be a cleaner way to write that, but this got our answer, so I'm just going to leave it like that. You might find a cleaner way to write that. Okay, let's do this one. This one does not have double angles in it. It just has cosine, one trig function, and all of the angles are named theta. And so we're going to solve this for cosine of theta. So this is a quadratic in nature. 4 cosine squared of theta equals 7 cosine theta plus 2. If you want to think of cosine theta as just x, you could think of this as 4x is 7x plus 2, 4x squared, and solve this little quadratic equation, realizing that x stands for the cosine of theta. So let's do that. This is 4x squared minus 7x minus 2 is 0. Okay, so you could use factoring if it factors. Do you think this factors? Oh, I think this factors. Let's just see what this factors into. 4x times x minus 2 plus 1. I think that factors. 4x squared, 1 minus 8 is negative 7, minus 2, this factors. So really, since x is cosine, we'll say this is the cosine of theta, the cosine of theta, 4 cosine squared theta plus 1 minus 7 cosine squared theta minus 2 is 0. All right, realizing that the x is really the cosine theta. Okay, so we'll solve this for cosine of theta. So 4 times the cosine of theta plus 1 is 0. You get that the cosine of theta is negative 1/4, and you get that the cosine of theta is 2. Right here, I'm going to reject this answer. The reason I'm going to reject him is because the output or the range of cosine curve is 1 and negative 1 is the most extreme values you can get. Anything greater than 1, anything less than negative 1 is not possible. I'm just going to reject this guy right off the bat. That means I have this theta I can find. Okay, so they did say they did give me a restriction here between 0 and 180. This is not a known value to me. It's not on the unit circle. So now I got to get my calculator out. So get your calculator out and let it help you. And remember, when you use your calculator, it's going to go for the, we're going to use the inverse cosine. And remember, inverse cosine pulls from these two quadrants. When it's cosine, cosine pulls from these two quadrants. So since it's a negative, it's going to be over here. This is the angle we're going to see in quadrant 2 that my calculator will give me. So let's see. I'm turning on my calculator. I'm going to make sure that I am in degrees, and I'm not. I'm in radians, so I needed to switch that. Now I'm going to take the inverse cosine of both sides of this. Cosine inverse of this side, cosine inverse of this side. And then I'm going to get theta is equal to, and it says it wants to four significant digits, or, oh, this is, or 6 significant figures or significant digits. So let's see. I'm going to use inverse cosine of -1 divided by 4, and that gives me this. I get 104.4775, and so 4 significant digits would be, I think they want 104.5 degrees. This is what I'm going to say. All right, so that is 1 that I get here. Let's see, that's over here. This is 90. That's going to be like that right there. If they wanted for all, then I'd have to add plus 360 degrees. But they didn't want for all, plus I'd have to find another one here, right? But they only wanted it in this range, so this is the only one that I find right there. So that's what I get. I'm not going to ask for significant figures. I'm going to ask for to the 10th place or something like that. All right, that's these two.